This is G484 Homework Booklet, question 17. The diagram shows the mass suspended from a spring. And in part A, you're asked to refer to the forces acting on the mass and explain what is meant by equilibrium. Referring to the forces is a question clue. So make sure you identify all the forces acting and then what the combined effect is. So in practice, that means that you can identify the two forces as weight and the force from the spring, which you could call tension, and then make the second point that the resultant force is zero. For this second point of resultant force is zero, the mark scheme would have allowed a number of ways of expressing it. You could have said sum of forces is zero, or upward forces equal downward forces, but do not say the forces are balanced. Many GCSE specifications and teachers talk about balanced and unbalanced forces, but it's not a term that OCR recognises at A level. The second part of the question is really just the definition of simple harmonic motion. There are always 2 points to make. Firstly, the acceleration is proportional to the displacement. And secondly, the acceleration acts in the opposite direction to the displacement. This can also be expressed by saying that the acceleration always acts towards the equilibrium position. And these two alternative phrases are usually both somewhere in the mark scheme. If you chose to start with the equation for simple harmonic motion, then it would be important to actually state clearly what A is, what X is, and the significance of the negative sign. We now come to a part of a question where it is using maths to express what's going on in this oscillation. So you have a specific equation here that refers just to this example. And from that you have to identify the frequency. Begin by making a comparison with the general equation for displacement that you would find on the data sheet. You can just match these two equations and look at the individual parts. Not needed in this question, but you can recognise that the amplitude is 12. What you want here is the frequency. So you need to identify that this term in brackets is equal to 2 pi f. After that, it's just a little bit of careful maths. Next mathematical step, finding the maximum velocity or speed. Again, this equation is available on the data booklet, so you just need to be aware that it's there for you to find, and careful substitution. Notice the answer is in meters per second, so you need to convert the amplitude from the previous part of the question here, 12, to 12 times 10 to the minus 3 in order to get into meters. The last part of the question is perhaps a little bit more challenging. It requires you to be able to interpret a graphical representation of simple harmonic motion. Make sure you do read the question carefully. When I was marking, many people missed putting a scale on the velocity axis. So you're starting with a displacement time graph, and you're asked to plot a velocity time graph. So you need to think about the relationship between those two quantities. Velocity is the rate of change of displacement. In other words, the points you're plotting on this second graph should relate to the gradient of the first graph. Here you can see the answer. Look at the gradient of the displacement graph here. It's negative and it's maximum at this point. Here the gradient is positive and maximum at a time of 0.6. And here it's negative again and of a maximum size at time equals 1. So here we have the 3 points, maximum negative, maximum positive, maximum negative that correspond. The gradient here at the trough and also at the peak are going to be 0, which give you the points where you cross the axis. You're asked to put a suitable scale on the velocity axis, and you have previously worked out the maximum velocity as 0.094 meters per second. So here you need to put a value on the y-axis and make sure your graph corresponds. The 3 marks in the mark scheme were awarded as follows. 1 for having a correct sinusoidal shape with a correct time period of 0.8 seconds. So that should be an easy mark. The second point's a little bit more difficult. It's getting this phase relationship right. So you would have to be coming down here to start with here, down along the graph there. And the third point is getting these values right and relating them to your y-axis.